All right, guys. Thank you so much for taking the time to be here wherever you are listening to this from, whether it be the morning, afternoon, or evening, or you're hearing this on a recording. We are glad to have you here to listen to the benefits of why you should actually get involved with this very special project called Camhirst 3DCP, and really how this can benefit you in short term and also in the long term. So, what I wanted to do is really have this Zoom with Adam Ahmed, the CEO, and Ed Rowland, the co-founder, to basically get a investor's perspective. So, what I really want this Zoom to be dedicated towards is the technical side, meaning the perspective side, the projective side, as far as why should people actually want to create any kind of investment into Camhirst 3DCP, as far as what is their possible generation of profits in the future. What is this going to bring them? How is this going to benefit people that are real estate developers? How is this going to benefit angel investors? How could this benefit construction managers, whatever the case may be, people that are building buildings? And also, what is the technology that goes into this specific product? So those kinds of things are really what I would like to go over today, and would like to keep this to about 45 minutes maximum. So I'll turn it over to Adam and we'll go from there.
Peter, thank you for requesting this Zoom, and it's exciting exactly where we have come with this project so far. And it is a startup, it is early days, but looking at that, I mean, the robot we have ready and the robots that we're going to be building in large quantities from the UK once the factory is up and running in the first quarter. These robots, I truly believe, are the best in the world. And what I'm going to do is, some of you have seen this video and some of you haven't. I'm just going to share, obviously, that 2-minute video, because those people who haven't seen the video, I can go over, it summarizes it very, very well, exactly what it is we're doing and what we plan to do in terms of helping companies around the world. So the bottom line is, this is YouTube again. Because I'm not signed in, you'll get these. We'll skip the ad. Okay. So look, bottom line is, the world is in a housing crisis, and this is an issue which is affecting every country. In USA alone is short of 4 million houses, which is an untapped $1.6 trillion market. Now, the traditional way is just too slow, and the huge shortage of skilled labor makes the problem even worse. Now, we at Camhirst 3DCP, it took us 5 years, millions of dollars invested. We've come up, we believe, with obviously the world's best 3DCP robots. Now, these robots, there are certain advantages, which obviously Ed is going to go over today, which makes us better than nearly all of the companies out there. And you can see in this video how the robot is building a house. And that house, a small house, we can build in 48 to 72 hours. And that's what makes it exciting, that the shortage is primarily because of shortage of skilled labor. And we're in a position to be able to resolve that housing crisis. Now, the houses are we can build more affordable homes, build them cheaper, less workers are needed, no forms for concrete, no steel. We could use basalt instead, faster drying cement, and companies can save up to 35% on the cost, which is amazing. And every time somebody buys a robot with training, we will train 3 people in our UK training center that we are setting up. It's obviously greener, more eco-friendly, which is huge. It's a big problem out there right now. Using geopolymer cement, it can be up to 95% more eco-friendly to produce. Now, you can see the video of the robot. That is geopolymer that is being obviously used there. So there's less waste. We can build more houses. Construction companies can make more profit. we can solve the shortage in any city in the world. And that's basically what we believe we can do. And the reason we're able to do this, which Ed will highlight even more, is because Ed saw the problem that a lot of these companies who are our so-called competitors, what they're doing wrong, and how we had to come up with something else. Even though this technology has been around for a number of years now, nobody's done it where building codes have been taken into consideration. Nobody's done it where people have taken into consideration the cost-effective side of it. Even in Dubai, where I am now, over a number of years ago, there's a building that was created because Dubai likes to be the first in everything. So there's a building here which was this is basically, it's like a museum which was created by using a 3D CP robot. So I'm excited that we're now at a position where we can actually have the factory up and running in the first quarter of this year. We already have some robots that are ready to go out. And these robots is where we have created some powerful crowdfunding models where people are able to together, the community together, before we bring in the venture capitalists, before we bring in, obviously, the angel investors, we're giving ordinary people around the world a chance to participate. We buy these robots at wholesale from our partner company, and we sell at retail, and that's where we're making 50,000 profit on the sale of the robot, or $10,000 profit per month if we're leasing it. So there are some unique ways how ordinary people around the world could be part of this project, which I will go over a little bit later once we've gone over the obviously technical side and some of the questions that people may have in their minds that Ed is going to go over. So we've got some very exciting ways that people right now can be part of this project and profit from everything we're doing in terms of empowering people, and also in terms of creating an income and creating profit, those who decide to get involved in some of those exciting things that we have created as a solution to help people and create prosperity. So that's the initial part from me, Peter. It's back to you.
Awesome. Well, thank you so much for that introduction, Adam. So let's turn this over to Ed. Ed, if you could briefly share a very quick background about yourself and essentially what brought you to Camhirst and what your background has been in this field, and why you believe that from an investor's perspective that people should really come into this company.
Okay, thanks a lot, Peter. Adam. I got involved in this almost 5 years ago now. When I found out that there were companies actually trying to build houses with 3D robots. I thought it was very interesting because I have been working in 3D, little small 3D printers for quite a while, and I thought this would be very interesting. And I studied architectural and mechanical drafting in college, so I thought this could be something to be interesting for me. So I went into it, worked with most of the companies that were in the space at that time, which most of them are gone now, but the ones that are still there, I know everybody there. And the main thing that bothered me is that they were not interested in, as Adam said, building codes, regulations, and that types of thing. And I said, this is more of a hobbyist thing than it is really constructing houses, on a large scale. So in 2001, I, with Stefan Mansour, we set up a committee where we actually wrote the ISO, the International Standards Organization, international standard, also ASTM in America, American Standards for Technologies and Materials, and TÜV in Germany, so that we have actually an international standard for 3D CP, which is 3D construction printing. And I think if you've ever seen a printer or a video of a printer, or ever seen a printer building a house, It's incredibly impressive. The first time you ever see it, it just totally blows you away, because they're actually using, it's a type of concrete. It's more like a mortar to build a house, to actually print a house. But I looked at that and I said, you know, we need to take this further. We need to make it better. I talked with a lot of different construction companies, with Heidelberg Cement in Germany, with Cemex in Italy, and the different companies in America and England. And my major question to them was, why is it the Egyptians, the Romans, the Greeks could build houses that could last for thousands of years, and we're lucky if we can get a building to last 100 years today? I mean, and it was kind of nasty, because I knew the answer to the question before I asked it. The concrete is not the same standard that they had back then, but the main thing is because they're using steel and iron. As soon as you put steel and iron into a building, it starts to rust and corrode, and as soon as it starts rusting, then the cement basically just explodes, because it has water in there and it breaks apart. And that really puts a ticking time bomb onto how long a building can last. So then I started into other things. We started using basalt, which is basically volcanic rock, made into rebar forms. You know, those bars that you see in they're usually done like this in the buildings. Basalt is very interesting because it's 82 times lighter than steel, but if you put it in concrete, it's 5 times stronger. Water, salt has no effect on basalt at all. So whether it's in water or in a moist climate or whatever, it does absolutely nothing to it. It will last it'll last millions of years, actually. Volcanic rock will probably last 4 or 5 million years without a problem. And that's where I saw a major advantage. And also using geopolymer cements, because the cements that are used right now, especially Portland, which is the main cement, is such a CO2 problem. If you're not in the construction industry, you don't know this, but the #1 used product on the world, or material, is water. That's pretty obvious. And #2 is cement. And for 1 ton of production of cement, they produce 85% CO2, which means for 1,000 kilos, they produce 850 kilos of CO2. You could just do that into the American standards and get the same thing. And then when you build the house, you're producing CO2 again. So you can get up to over 100%, which means billions and billions of tons of CO2. And if you use geopolymer, you can reduce that by up to 95%. Also, geopolymer is 100% waterproof. It's anti-allergenic. It lasts much longer. You can get geopolymer to last thousands of years, which concrete, it's just not going to happen with concrete. It has a tensile strength and a compressive strength, which is way above that of concrete. Can be with concrete, you can get about 8,000–9,000 pounds per square inch pressing against the concrete before you have problems. And with geopolymer, we have geopolymers that are doing 19,800, very close to 20,000. So it's a completely different world. And I just been doing this research and everything for 4 years, working with the different companies and trying to get it as good as we possibly could. Our first robot was very good, but it weighed 2.7 tons, which I thought was too heavy. Our second robot was better. It weighed about 1.8 tons. And now our third robot is just below 500 kilos. So we're getting better. Our robots are getting faster. We have the only robot system where we can use multiple robots when we're building a house. Most of them are using a gantry system, which is basically just 4 legs outside of the house, and they print inside, which limits you because you can only build like 3 stories, because you can't build the towers, to build high rises. We can print from the inside, and we can also use multiple robots, which just exponentially increases the speed. Even though most of these companies can build a house in 48 to 72 hours as well. What they don't mention is at the base of these posts, they put a foot there. And these feet are concrete, cast concrete, which weigh 3,800 pounds each, which they leave when they go. I don't know what the heck you would do with 12,000 pounds of concrete, but they leave it there, and they have to wait 28 days for that to finish. And after that, they can print in almost the same speed that we can with 1 robot. Now, if we're using 3 or 4 robots, we can be 6 or 7 times faster than they are, which is already about 20 times faster than conventional. So there's just a lot of advantages. I could go on. I mean, I could go on for hours about geopolymer. I could go on for hours about basalt. I could go on for hours about 3D CP, because I've been doing this for so long and I've seen so much. And we've written the standards, international standards, for 42 countries. We're now on the second and third standards that we're writing right now with different committees. It's a very interesting field, and everyone in the construction industry agrees this is going to change the construction industry forever, because the speed at which we can build houses, and you usually have a 3-man team on a robot. So you're talking 3 people building a 200 square meter house, which is, I don't know what that is exactly in English. Somebody will have to figure that out. I think it's like 2,000 square feet or something like that, in 48 to 72 hours, building the floor and the walls. You just really can't touch that. And if you're using multiple robots, it's even faster. And with the housing prices we have, it's really the only way to do it. There's no other way to do it at all. This is the only way that you're going to get that many houses built in that period of time, to meet the housing prices and the problem that's there. Okay, I'll turn it back over to you. Thanks a lot.
Awesome. Thank you so much, Ed, for that explanation, and so well articulated. I think one of the things that a lot of people on this call, are very familiar with Camhirst to an extent. Some are not. But what I'd like you to touch on is, let's just say somebody wanted to buy a robot. From what I understand, each robot costs $250,000. So if you wanted to buy a robot for $250,000, how quickly, would you be able to recoup your investment per se? In other words, how fast can you turn that around to creating profit for yourself?
It's kind of a loaded question, because it really depends on how many contracts you have. If you could get the contracts, you could make right at 100,000 per house on like the 200 square meters or 2,000 square meters, or 2,000 square feet or 200 square meters. You could make 100,000 per house, and if you're paying 200,000 for the 250,000 for the robot plus 25,000 for the schooling and everything, you could make your money back in a month. Normally, I would say 2 to 4 months you'll have your money back, because you've got 3 people that you're paying. You want to pay them above the wages that a normal construction worker is getting paid, because they are robot operators. But you're still going to be making a ton of money on each house. So if you're looking at making 50 to 100,000 profit on each house, and you could possibly do 4 or 5 houses in a month, you can definitely do 4 or 5 houses in 3-4 months. So if you're doing 4 or 5 houses, then you're looking at making between 200 and 500,000 euro in about a quarter of a year, in 1 quarter. So that's unbelievable. Nothing in the construction industry can touch that. Yeah,
that's impressive. And then, so now when it comes to the factory, and really that's really the next goal, is essentially getting the factory up and running in the UK. The estimation for that, I believe, is somewhere around March or April. Is that what we're looking at right now?
Sort of end of Feb, towards around Feb, spilling over into March.
February into March.
Yes.
Okay, and there will also be provided with a tour of the factory for people, so that they can come and see it and things of that nature.
Whoever's a founder, yes, they can book in a tour of the factory.
But it's not only a tour. They'll actually be able to see the robot operating. They'll see that robot building walls. And I always say building walls, because any building on the planet consists of walls. That's what's holding the ceiling up. That's the most important thing, is your foundation and the walls. And they'll actually see us printing walls, and they'll see the way that the printing process works. They'll see how fast it is. We're talking a printer that can go 500 to 600 millimeters a second. So it's very fast. It's incredible the speed at which we can print. And when you see this thing printing and you see that the wall just getting higher and higher and higher in a very short period of time, then you start to realize what an unbelievable advantage you have when you're building with this. And because the interior part of the wall, you print the outside here, and then you have the interior, which you can make up to like 50 centimeters, which would be about, what would that be? About 15, 16, about 18 to 20 inches interior. And then in there, you can put in your rebar or whatever you want to put in there. If you have a load-bearing wall or whatever you want, you can basically put anything in there. Also for insulation, you can put in aircrete. So it makes your structural integrity much higher, but it also insulates incredibly well because millions of bubbles in there. For electrical, plumbing, and everything, because you've got an empty space in there, when the electricians and plumbers come in to put the things in the house, they always say, wow, I came here thinking I was going to be spending 4 or 5 hours, and in 45 minutes, I'm done. Because, just throw the stuff into the middle and pull it through the holes and you're finished. So there's no cutting and trying to figure out how to do whatever, placing pipes or placing cables or anything, because you have that empty interior. It's just, it speeds the whole process up for every single thing that you're doing on the house.
That's great. And then would you also say that with the geopolymer and the way that this material is designed, is it also designed to heat better?
Yeah, we've actually got a video where we burn a house down with the fire department there, and you could see that while the house was burning down, it was like 800 degrees Celsius. That's like 1700 degrees Fahrenheit on the one side. On the other side of the wall itself was about 42 degrees. So it was about 75 degrees. No, about 90 degrees, I think. And inside the room, it never got over about 80 degrees while the whole house was just burning down. That's the thing about Portland cement. Portland cement can take temperatures up to about 600-700 degrees for a very short period of time, because it always has water in it. The water just starts exploding and the wall explodes and the whole thing just comes crashing down. But geopolymer can take temperatures from 3,000 to 4,000 degrees for hours. We're talking 4 to 6 hours, sometimes even 8 hours. No house fire is ever going to get to be more than about 900 degrees Celsius, which I think that's about 1,500 degrees Fahrenheit. No house will ever get any higher than that. And if you're talking about being able to sustain temperatures in Fahrenheit that are way in the thousands, they're like 6,000-7,000. I don't know. You'd have to look it up, but it's about 4,000 degrees Celsius. Then there's no normal house fire that could possibly do anything to this wall. My comment is always, if you have a fire in the kitchen, close the door. And people say, what? And I said, I didn't say close the door and order a pizza and watch a movie. Close the door and call the fire department. But it can't get out of that room because there's no way for the fire to get through the walls at all. It's totally impossible. If the ceiling is also made of geopolymer, it can't get through the ceiling either. So you on the one side, it's fantastic, because if you're not in that room, if you're in the room, it's not, could be a problem. But because of that, the insulation properties of geopolymer are unbelievable. We also have a video where we actually made like a vase thing, and we poured melted steel in there. It's about 3,000 degrees, and you could put your hand on the side while you could look inside, seeing glowing melted steel on the inside. You could put your hand on the side. So the thermal properties are astronomical. They're very, very high.
So let me ask you this question, because I know this is another question that has come up within my community, is that the wind tolerance. What is the wind tolerance for this material as well?
That would depend on what type of rebar you use, how much rebar you use. You can get an incredibly high wind tolerance if you use quite a bit of rebar. I would suggest to use basalt always, because basalt is very flexible. You can actually bend basalt like this. Kids can bend basalt. It's not a problem. But once you get this into concrete, it can be up to 5 times stronger than steel, which means if the wall starts moving because of the wind, the wall's not going to come tumbling down, because that flex can take up the space to which the concrete would normally break. We actually did tests where we press beams where there's concrete with steel rebar in there. The iron or steel rebar doesn't hold very much. With basalt, it's very difficult to get it to break. It'll crack, but it won't actually break. So I think most hurricanes, the walls would be able to take most hurricanes and most tornadoes. If the tornado does not lift the base of the house up, then I'm pretty sure that the walls could take any hurricane or any normal tornado or whatever. So I think probably up to 200, 250 miles an hour, I don't think it would be a problem if you've got, the basalt and everything. If you're building like in Florida or for hurricanes, or in like the Midwest in America for tornadoes, you would obviously, look at what type of structure. And because you have the empty part in the wall, you can we have a system that I did myself, which I call a spider web system, which basically you have basalt going this way, basalt going this way, like this, and basalt going this way, to where it sets up like a spider web system in there. And through that spider web system, the wall is almost like steel. So it's pretty close to unbreakable. But the amazing thing about geopolymer, which you can't do with concrete, is you could tear the house down, crush up the geopolymer, and use it with the basalt in it if you want to. You could use it 1-to-1. You don't have to do any filtering. It's 100% recyclable. And anyone who's ever dealt with recycling concrete, it's hell, because you've got to put so many filters through this that it's absolutely incredible. Geopolymer is really 100% recyclable. You can just crush it up and directly use it again.
Awesome. Well, I think for the most part, I think that really goes over that side of things. So what I wanted to do is really, there's about 20 people on this call. So do me a favor, guys. If you have a question that you want to ask either Ed or Adam, raise your hand in the chat, and it's very simple to do so. Just basically click on your name and click raise your hand. You'll see a little icon that has a hand raising. And so if you want to raise your hand, you can do that and basically ask a question, because we don't have the chat enabled. So that's the only way we can do it. And then essentially Adam can go ahead and unmute you. And we can go from there. But, I think really what I wanted to stress today is basically what is, the importance of really why this is so beneficial and how early we are in this. So, all of us having this capability to be founders in this project, or to just be, angel investors or people that are real estate developers, whatever the case may be. If you want to buy a robot, if you want to be a founder, if you want to really invest into this project, you heard what Ed said, and you heard the solidarity behind this project and the impact of really what this will bring to the construction industry going forward. And it's just really a matter of time, really. I guess the only question that I would say, which is probably on a lot of people's minds that I know, Ed, is as far as the United States goes, how easy is this going to be to implement?
Okay, it's already been implemented. Icon in Texas is doing big business. In fact, they received, I think, $480 million in investments. So they're doing pretty good. Apis Core in Florida is also doing very big. There's Mudbots in Arizona, or I think Nevada, I'm not sure. There are quite a few companies now doing this. Also, Cobalt is a Danish company who's also in Florida and a few other states in America. So it's already being implemented in the United States, and they've already built houses in a lot of different places. So it's very new, but they are building houses in Virginia, I believe. Yeah, in Virginia, there's now a project where they're going to build 200 houses using 3DCP. And I think New Mexico, there's also a project where they're going to build 200 or 300 houses using 3DCP. So it's being implemented, it's being done. It's just in the early stages. But I would say within the next 2 to 3 years, there's going to be companies with projects where they're building thousands of houses with the robots. It's just a matter of time now.
Okay, awesome. So Adam, in the chat, there are 3 people that have their hands up. So let's just go in order. So we have Glenn. So if you want to unmute Glenn, he can ask a question.
Then go ahead. You can unmute yourself.
You're unmuted, Glenn. Go right ahead.
Glenn, we can't hear you, but we can see your mic is unmuted. So what we'll do is, as we can't hear, Glenn will come back to you in a bit. I'm just going to go over to Caroline. Caroline, you can unmute yourself.
Good morning, thank you. So I was wondering, I have heard of the Icon robot that Lennar is using, and I was wondering, can you compare the Camhirst robot to this Icon and Cobalt and the others that you mentioned?
Yeah, sure.
Is
Sure.
this specific robot, the Camhirst robot isn't being used currently in the US, is that correct?
Yeah, we've used it in the US. We've used it in Las Vegas and now in Florida. Yeah.
Oh, okay. So I'd love to know about those projects so I could check it out, and also obviously the comparison between those other robots.
Okay.
Thank you.
The Cobalt robot is, like I said, is a gantry system with the 4 big legs. They need cranes to set it up, construction cranes, and it takes quite a while. And they have to do to cast the feet, which are like 3,800 pounds each. So it's a huge process. It's not hours where we can just come in and start building in a few hours. The Icon robot is very close to ours because it's a Cartesian system using, it's a 2-legged system. The only difference is that the Icon robot is also outside of the house. So it's on a track and it prints inside. It just goes down the track, it prints inside, which ours is also on a track, but we can print from inside or outside of the house. So it's very close to what the robot does. It's just a lot more flexible because ours is smaller and we can use multiple robots at the same time. And with any of the other ones, Icon or Cobalt or whoever they are, they're only really using one robot because it's on the outside of the house. The robots would basically run into each other. It would be impossible to do. So that's our major advantage, is that our robot's a lot smaller, a lot lighter. It's faster to set up. We can set it up in like 3 to 4 hours. They're looking at least a couple of days, 3 or 4 days sometimes. And with Cobalt, sometimes even 30 days when they're kind of complete.
Wow.
And also that none of them have come up with the idea of using, they come up with the idea, they just haven't done it, of using multiple robots at the same time. So, if you're looking at a really big project like a shopping center or hospital or something like that, we could put in 20, 30 robots working at the same time. So we would be finished like 30, 40 times faster than anyone else. And that's the major advantage. And also building high rises. Any robots working from outside of the building, they can't build high rises because they can only go up to like a couple of stories, maybe 3 stories, and then it's over. And because we're building from the inside to the house or the outside, we can build to any height It doesn't matter. In fact, in Dubai, there's a project going right now that's using a robot very similar to ours. And the building they're building is called the Tower of Babylon, and it's going to be 730 meters high.
Wow.
It'll be the tallest building in the world, and they're going to be using 3D construction to do it. You can look it up in the internet. Tower of Babylon, Dubai, the information be in there. But ours is, like I said, ours, we use multiple robots. It's much lighter, it's much smaller, much more flexible. We have a lot of things. We also can print walls in the middle of the house and then move them to wherever we want them to be. And then the person can walk through and say, oh, this room is too small. And you can actually move the wall and say, okay, move it. Which no one has come up with that idea either. We've got quite a few things that we're patenting right now, which no one has come up with the ideas before. That whole spider thing with the basalt, no one's come up with that either. We're patenting. We have 7 patents we're working on right now. So we have quite a few things that no one else is. And no one's using geopolymer except us. No one's using basalt either except us. So, yeah. Okay.
Amazing. Thank you so much.
You're welcome. Thank you, Carolina. I'm going to...
Thank you, Caroline.
Thank you.
Okay. We've got Dee. I've just unmuted you. If you want to go ahead.
Hey, Ed. Hey, Adam. Ed, I believe you just answered my question, because I was just going to ask, has anybody using the technology Geopolymer? One of the reasons why I came into this amazing journey right here is because, the technology behind it, no one is using I've done my research. I've seen some of the homes, they're built on concrete from 3D technology. Habitat Humanity created their first home in Wilmington, Virginia, a 3-bedroom home. I saw that. I did my research. I am a founding member. I'm so excited. But when you answered the question, the question that I was going to ask. Has anybody or is anybody using the technology that you're using? Because the technology to me seems to be more powerful than any technology that I've seen, as far as what they were talking about. When I did my research, nobody talked about the geopolymer, that technology being used and everything. And fireproof is one of the things that I really took part in this, because I lost 2 homes in a fire. And
Wow.
so, they're not easy to fix. And I tell you, 2 months ago, in August, I lost my home, and they still have not begun the construction on that home yet. So, rebuilding and refixing it up. So it is a lot. And so you have explained everything that I needed to know, and, details. And I'm just really, truly blessed to be here. This is going to be a game changer. And, with that, I just want to just say thank you for everything. Adam, thank you, Ed, for giving a more explanation on it. Thank you, Peter, for having this call. We need this. This is going to be very powerful for our leaders to be able to see this and, take action. I'm truly blessed.
I got a question. Are you from Virginia?
Yes, I am.
Okay. I'm from North Carolina, so yeah.
Well, that's right up the street.
But the group you were talking about, they actually are part of the group that's building 200 houses in Virginia using 3D CP, which I think is fantastic on the one side. On the other side, they're not using geopolymer. They're not using basalt. We're talking about building buildings that can last over 1,000 years.
Absolutely.
Why, if you can do it, why are you not doing it? Why are you building houses that last 100 years? I can tell you why you're doing it. Because then I can come back with the next generation, build another house, the next generation, build another house. We want to build houses that last 10, 20 generations, because we can. And that's the whole thing. If you can, why are you not doing it? If you can build 95% more environmentally friendly, why are you not doing it? If you can build fire safer, why are you not doing it? And I always say that these companies know that you can do it. They know the technology is there. I just asked myself, I know the construction industry has lobbies like hell. I know the concrete industry is one of the biggest lobbies in the world. The steel industry is one of the biggest lobbies in the world. I understand that they all have their hands in the pot there. The same thing is like the gas industry with cars and everything. But what I say is, if you're destroying the environment, and you can be 95% more environmentally friendly using geopolymer, it's almost the same price. it'll last 1,000 years. It's fireproof, it's waterproof, it's chemical proof, it's anti-allergenic. You can drill a hole in the wall and screw the screw in the hole without putting plastic in there or anything like that. If you've got all of these advantages, why are you not doing it? And that's the reason I did this. Is I said, this can be done better. This can be done much better at the same price or even a lower price than the price of normal concrete houses. Thanks a whole lot.
Thank you for the explanation. Right, Glenn, let's try you once more. Let's see if you can unmute yourself. Glenn, I've tried to unmute you, but I think
I'm on the phone, which is GL. So sorry
okay,
about that.
good. Yeah, you can go ahead, Glenn. Please ask your question.
Yeah, I've actually got a few questions, 3 questions, if I can get them all out. But one is, how soon can we expect to see a large buildings being built with the current robots you have? I mean, are we shovel ready? Are we ready to go? And then that's one question. I'll come back to that. Another one is, when you're building up in stories, how how do we keep going up and up the 3,000 meter, however high that Dubai Tower was going to be, the Babylon Tower? How do they do the interlayers between the floors? I mean, they laying floors as they go, that kind of thing. And then the third question is, I'm still a little confused on how you're laying the plumbing and the electrical. Is it laid as it's built up, or I mean, is a conduit laid as it's built up, or those kind of 3 are my biggest questions.
Okay. As far as when we can start, immediately. The robots are finished. Alpha beta testing is already done. We've actually built walls. So we can build immediately. As soon as the factory's up and going and we start producing the robots on a larger scale, then we can start building at any time. As for when will we be building large buildings, we have contracts right now, which Adam could probably tell you more about because he's been in Dubai since the 1800s, it feels like. He's been in Dubai for, I think, 15 weeks now. So talking with people from Africa and Dubai, Saudi Arabia, and a lot of other different countries. But we actually have contracts now, which we're going to be building larger buildings, very large buildings in Africa, and it looks like it could be Saudi Arabia as well. As far as the plumbing, electricity, and everything is concerned, basically any building that is built is done, the whole plan for it has to be done in a CAD system. And that CAD system has to be BIM certified, which is building management information. It has to be the whole system. When you start putting all of this stuff in there, it has to tell you, this wall needs this amount of rebar in there for the structural integrity, and where the pipes are and where the electricity, and everything has to be in there. And based on that is what our computers use with a splitting software to print the building. So the places where the pipes, electricity, and everything come out of the wall will be printed. So they'll already be there. As far as the pipes and electricity inside of the wall, because it's completely empty, you just have to put it in there and just make sure it comes out the hole where it was specified on the plans to come out. So because the walls on the inside are completely empty, you don't have to worry about if you make any mistakes or anything, because you just put the stuff in and take it back out. I mean, once everything is in place, the walls are filled, but up until the point where they're filled, it's pretty easy. As far as building layers on top of each other, there's different ways of doing it. We have a flooring system where we actually just use blocks to build the floors out. And then they're supported by a cement and basalt system, rebar system, the same as any other high-rise system would be built. And then once the floor is finished, then we can put our robot on top of that and just build the next layer. And then once that floor is finished, put the robot there and build that layer. And the robots are very small, so we can do most of it with small forklifts or very, very small cranes. We don't need huge cranes like a Cobalt or one of these other companies would have, where they have like 10, 15 tons. I know Samsung has one called Black Buffalo. Everyone should look at Black Buffalo. That is a big, big, big thing. That is like an elephant. And it weighs megatons. And that, yeah, something like that's impossible. But ours is so small, we can basically just put it on the floor and just print from inside the building without a problem. That's the way you would do high rises, is you would just keep moving the robot up to the floor and it would print from the floor from inside the building. Okay, I hope that answers your question. The questions?
It does. Thank
Okay.
you. And then one last thing would be as you're building, gosh, what was it? Never mind. I'll have to come back with it if I remember.
But if you think of it again, just let us know. No problem.
Thank you so much, Glenn. Great questions there. Okay, everyone. So what I want to do, because I'm very time conscious, I just want everybody to know as well that, look, I basically, we have got investors now who are ready to go ahead. And the challenge was that one investor in particular wanted to put money into a Dubai company and into a Dubai bank account. So for that, I've got delayed and I had to stay here. And so what I've been told, my passport will be back. So I've had to create an LLC company here in Dubai. I've had to obviously get a residency here in Dubai. The head office will be based in Dubai, but the factory will be based in the UK. So I've been told that I will have my passport one day next week, because they've managed. There was a little issue with it in terms of the address and a number of other things. So the good news is that I'm now at the last stage of getting that bit done. Investment comes in, I go to the UK, we set up the factory, and we start building. One of the things that we must understand is that when the investor comes in, and I'm talking to two people we are going to be bringing on as stakeholders. When you have a stakeholder, you have to listen to them as well. This is the bit I want everybody to understand, that that right now, what I have done is going back to what I believe in, which is empowering people, which is about creating prosperity for ordinary people. That's why we created these extremely generous ways for people to be able to profit from our system. Now, so if we go back to the founders plan, the founders is unbelievable. You pay $1,000 and you become a lifetime member of the private club. And that private club, the profit will be shared for a lifetime. So that $1,000 also giving you, of the founding members position, 50,000 free tokens and plus many of the benefits. But remember, I give the example that if we make $250 million, then the 5% is 12.5 million. That's 12,500 per member that the private club will share. And if it's 500 million, it'd be double that. If we become $1 billion company, and remember, every quarter, once we're in profit, we distribute the profit, those people are getting a passive income. And later on, that passive income could be a substantial income. So if anybody hasn't become a founder, once those 1,000 positions gone, they're gone. Now, right now, if you refer somebody up to midnight tomorrow and they become a founder, you are getting, as a person who's referring them, 100,000 free Cam3D token. That finishes tomorrow night. Same time, if you introduce somebody and they participate in the fractional ownership, then you'll 1,000 or above plan, you'll also get 100,000 Cam3D tokens as well. So as the referrer. Now this promotion is on till midnight GMT tomorrow night. In New Year, it will not be there. These additional tokens. Then the other thing to bear in mind is that the fractional ownership program we have created is beta. It's a trial, and it's only 250 people. And it's for a limited time period. And why is that so exciting? It's exciting because I don't know whether we'll have a V3 or what V3 will look like. So if now, whatever kind of trading or minting or whatever people have done in the past, that's risky. We're talking about robots, real estate, solving the global housing crisis, and we're talking about, you know, daily rewards on the fractional program. How does it work? Very simply, people are participating, putting the money together. We're using that money for the robots that are ready to be shipped out, you know, in the USA. Your money is going towards funding let's say a robot, and we've received the deposit, so hence we can start distributing the profits immediately. We will then, once obviously it's ready to be shipped, boom, escrow money comes in, we distribute it again. It's a powerful plan, and you could also compound it. So if you had a 5,000 plan, so you can go on fractional ownership from 100 to 5,000, and you made $100, you could buy another plan. So you could buy another plan, so that you could be having a compounding effect. And that, Einstein said, compounding is like the eighth wonder of the world. So fractional ownership is limited, ladies and gentlemen. If you don't take advantage, you're going to be kicking yourself, because it is a very safe way to participate as a community and share the profits. When the stakeholders are in place, it's not only my decision. Right now, it's mine and Ed's decision. We're happy to do this while we can. Now,
Can I say something real quick, Adam?
go ahead. Go ahead.
I always, there's a few little, I don't know, cheesy things that I say, I guess you call them cheesy. One of them is, if you had the opportunity to invest in, to print money or to print houses, which one would you choose? And a little tip, one of them is legal and the other is not. Printing houses is incredible. I mean, the real estate industry is the largest industry in the world, very obviously. Just look at the buildings in the background of Adam's picture here. And you can see, I mean, the construction industry is absolutely huge. And if you can print houses, like I said, on a standard house, someone buying one of these robots can make 50 to sometimes 500,000 euro or dollars. So the profits are incredible, because you're talking about a three-man team. You're talking about a three-man team printing for 2 or 3 days, and you turning a profit of $100,000 or 100,000 euro. That's incredible. That's unbelievable what you can do there. Another thing, as far as waste, because we're using these huge bags for the cement, my saying is always, on a construction site, you're looking at over a ton of waste, usually for a house. And my saying is always, if one of our guys was eating a Snickers or a Mars and he threw the package on the ground, that's our waste. We don't have anything else. So, you know, we're looking at over 95% more environmentally friendly. We're looking at almost no waste, and we're printing houses. This is really the future. Everyone in the construction industry knows it's the future. You don't have to believe me. Go online and Google it and look at what's happening in the 3DCP area. And also look at the International Standards Organization. If you want more information, we can send you on the 3DCP international standard by ISO, in America by ASTM, and in Germany by TÜV, that we wrote. The people that work with me, we wrote this standard. So we really know what we're doing. We really have the best people in the world. We have people from 42 countries for the standards organizations from 42 countries working with us to make sure that we can get the building codes, the building standards, and everything that we need for all of this. So this is happening. It's just a matter of, are you going to be a part of it, or you're not going to be a part of it? It's definitely different than anything else that I know of that you can have a chance of getting in on the ground floor on, because there's just, as I said, print houses or print money. You print money, you're going to get caught. Print houses, yeah, you can print. That's not a problem.
Amazing.
Okay.
Thank you so much. Now, very quickly before, because I know time is against us, the token, the promotion, double free bonus tokens ends midnight tomorrow. Now, please understand, I've been in the space 6-7 years. I've got some of the world's experts working with me. We've got a great marketing company. We've got an amazing use case for this token. We have had to move the launch date of the token to 27th of March, simply because we want the token to be a big success. And the viral marketing that will happen once we do the press conference and press release, that is obviously going to happen once we launch, obviously open the factory. So don't miss out on the token promotion. Don't miss out on referring people to fractional ownership or the founders program. This is allowing you the chance to profit, just like the big boys, venture capitalists and angel investors, people who got a lot of money, they only get the chance to come in at this stage, and we're allowing ordinary people to be part of that and profit at the early stage. So back to you, Peter, to close the call, because I know you have another call shortly.
Yes, thank you so much. I appreciate everything that you have said, Adam, and how special this project is. And, you know, we're at a really, really good place with everything. And of course, Ed, everything that you have shared has been absolutely phenomenal from an
Thanks a
investor.
lot. I think Caroline has a question, if we've got time for that.
Caroline, is it a quick one? If it's a quick one, then
And I'll connect Caroline to you and me on a different call, because I know Peter's got another call shortly.
yeah, let's do that. Let's do that. Okay, sounds good. All right, appreciate it. Again, thank you, Ed, so much for everything that you have said. I think it really
Thanks a lot.
brought
You're welcome. Always
Respect.
love talking about 3DCP and geopolymer basalt, man. I'm into it. That's my babies.
Thanks, guys. Appreciate it.
Thanks a lot. Bye.
Thank you, everyone. Take care, and have a
Thanks,
fantastic
everybody.
day. If we don't speak before,
Goodbye,
have a
everyone from
fantastic New
Spain.
Year. Bye-bye. Take care.
Thanks. Bye-bye from Spain, guys.